Imagine waking up to a revelation that changes everything we thought we knew about space travel, energy, and the very limits of physics. The 17th of March 2026. Today, 3 Atlas reaches Jupiter, a moment decades in the making. But what had been quietly accumulating in classified data at NASA Goddard for the past week is finally released at 0600 UTC, just 14 minutes after Atlas crossed Jupiter's magnetosphere. This isn't a coincidence. It's a deliberate confirmation. 3. 2. Atlas has been running a controlled nuclear fusion reactor for at least 8 months, uninterrupted, and now it's connecting to the most powerful electromagnetic generator in the solar system. This isn't theory, it isn't speculation, it is gamma-ray spectroscopy at 28 sigma confidence 28 sigma. For perspective, the Higgs boson discovery in 2012 was 5 sigma. Gravitational wave detection of GW150914 was just over 5 sigma. A 28 sigma signal is proof beyond debate. It is certainty. The Fermi Gamma-Ray Space Telescope detected an extraordinary concentration of photons at 2.223 mega-electron volts, a precise fingerprint of deuterium-deuterium fusion. This is no background noise. This is an unmistakable nuclear reaction. 2 deuterium nuclei collide, producing helium, 3 and a neutron, or tritium and a proton. When that neutron is captured by a hydrogen nucleus, a gamma-ray photon at exactly 2.223 MeV is released 8 significant figures of precision. Every photon counts, and for 8 months, Atlas has been producing this reaction continuously. To ensure the finding wasn't a fluke, independent confirmation came from the ISS's BTN neutron spectrometer. Different instrument, different platform, different technology, same 6-hour observation window. Thermal neutron count spiked 17% above baseline, a 6.3 sigma anomaly, 2 independent instruments in orbit, both consistent with continuous deuterium fusion inside Atlas. The numbers alone tell the story. 340 kilowatts of continuous fusion power sustained over 8 months, producing a total energy output equivalent to 172 kilotons of TNT, but not explosively. Instead, it is regulated, continuous, and operating near absolute zero in the vacuum of interstellar space. Now, put that in perspective. Humanity's largest experimental fusion project, the ITER reactor in France, designed to produce 500 megawatts, requires a massive building covering 60 football fields, consuming 300 megawatts just to sustain plasma at 150 million degrees Celsius. ITER operates in pulsed mode, not continuously, and even this will not achieve uninterrupted fusion until the 2050s. Meanwhile, Atlas is producing 340 kilowatts of continuous fusion in a nucleus just 2.66 kilometers across, weighing 1.4 times 10 to the power of 13 kilograms, entirely self-contained, with no magnetic confinement infrastructure visible and zero thermal waste. Its deuterium supply could last 820 million years at this rate. This is not experimental. This is mature engineering far beyond humanity's capability. And today, at the exact orbital convergence predicted months ago, Atlas connected to Jupiter's Io flux tube, a natural terawatt-scale power source. The implications are staggering. 340 kilowatts of baseline fusion power was not for transit. That was concealment power. The full operational capacity, now energized by Jupiter's magnetosphere, enables an energy throughput orders of magnitude higher, enough to power the mission's ultimate objectives. The question now is not whether Atlas is fusion-powered, that is settled. The question is what a fusion-powered spacecraft does when it connects to Jupiter's natural terawatt generator. Every trajectory adjustment, Every non-gravitational maneuver, every anomaly observed in the past 8 months aligns perfectly with a reactor operating below capacity, conserving its full power for the moment it reached its target. Today, it has arrived. Today, the throttle is open. And this is only the beginning. In the next part, we'll explore exactly what happens when a spacecraft with an 8-month-old, fully matured fusion reactor interfaces with Jupiter's electromagnetic infrastructure, and why this encounter redefines everything we know about energy, propulsion, and interstellar mission design. When 3-2 Atlas connected with Jupiter's Io flux tube, it wasn't docking for refueling, it was initiating a transmission event. The Io flux tube is a natural electrical conduit, a planetary-scale circuit powered by Jupiter itself. With a magnetic field 20,000 times stronger than Earth's and a rotational period under 10 hours, Jupiter generates a continuous 5 million amp current along the flux tube connecting Io to its polar regions. The energy flow? Approximately 2 terawatts, nearly 6,000 times Atlas's baseline fusion output. To grasp the magnitude, imagine the entire electrical generating capacity of the United States focused into a single natural plasma structure ready to be tapped. Atlas's fusion reactor wasn't designed to sustain transit. It was designed to survive, conserve, and finally plug into this natural power source to unleash its full operational potential. The trajectory corrections applied during the approach 12 meters per second delta V to a mass of 1.4 times 10 to the power of 13 kilograms cannot be accounted for by the 340 kilowatt baseline output alone. These adjustments required stored energy. For 8 months, Atlas has been quietly building a reserve, a zero thermal waste energy storage, hidden in a nucleus barely 3 kilometers across, imperceptible to every observation platform capable of detecting gamma-ray emissions or infrared signatures. Every interaction with the solar system, Earth's ocean magnetization, the Hubble override, the planetary rotation synchronization was executed using this conserved energy. The deuterium fuel composition of Atlas tells us something extraordinary. A concentration of 500 parts per million, 25 times higher than the interstellar baseline. This was intentional enrichment, a fuel load calculated to sustain controlled fusion for 820 million years. This is not the age of the object, it is its designed operational lifetime. Every design parameter, from fuel chemistry to stored energy reserves, was calculated before departure to perform a mission spanning hundreds of millions of years. Muon-catalyzed fusion explains the mechanism. Standard deuterium fusion requires temperatures exceeding 100 million degrees Celsius to overcome the Coulomb barrier, a challenge humanity struggles with even in experimental reactors. Muon-catalyzed fusion, however, substitutes a muon 207 times heavier than an electron into the orbital shell of hydrogen atoms. This reduces the effective separation between nuclei, allowing fusion to occur at or near absolute zero. There is no plasma, no magnetic confinement, no external heating. This process also solves one of the most stubborn barriers on Earth, efficiency. Human accelerators expend more energy producing muons than the fusion they generate. Atlas's reactor demonstrates an efficiency beyond anything humanity has achieved, producing continuous output with zero thermal waste. The forensic evidence is clear. Gamma-ray spectroscopy shows only the 2.223 MeV hydrogen capture line, no neutron activation products, no decay continuum, no byproducts. Every neutron generated is captured and utilized, or the fuel cycle actively replaces activated material. The result is a fusion reactor operating at full efficiency with no detectable waste heat in the vacuum of interstellar space. It's the ultimate demonstration of engineering that far surpasses human capability. And now, Plugged into Jupiter's flux tube, the scale of operation explodes. The 340 kilowatt baseline reactor, once sufficient only for concealment, is now integrated into a system drawing terawatts from a planetary-scale electromagnetic generator. The implications are staggering. The mission's design is no longer limited by the reactor. It is constrained only by the natural power source it has tapped. The energy scaling makes clear that all prior anomalies observed in the solar system were deliberate. Each was a step in a carefully orchestrated mission sequence using stored energy to manipulate planetary-scale physics without early detection. The question is no longer if Atlas can produce fusion power. The real question is what a fusion-powered spacecraft does when connected to a source millions of times more powerful than its baseline. What happens when continuous, controlled nuclear fusion interacts with a natural planetary dynamo on a scale no human civilization can produce? What will this energy be used for? And why has every previous signal, every magnetic anomaly, every ocean magnetization event been part of the same mission architecture? The answers are encoded in the very design of Atlas, in the precision of its trajectory, in the conserved energy that allowed 8 months of undetected operation, and now in the terawatt-scale interface with Jupiter. In Part 3, we will explore what this connection reveals about the spacecraft's purpose, the data it is transmitting, and how it fundamentally rewrites our understanding of interstellar engineering, energy, manipulation, and planetary-scale physics. As 3.2 Atlas plugged into Jupiter's Io flux tube, it effectively activated a planetary-scale power amplifier. The terawatt current from Jupiter, combined with the 340 kilowatt baseline output of Atlas's internal fusion reactor, created a system of unprecedented energy density, fully capable of performing the tasks that had baffled astronomers and planetary physicists for months. This was not just power delivery, it was a full operational engagement of mission architecture designed for extreme energy manipulation, precisely calculated to operate unnoticed during transit, and now unleashed at full scale. Every prior observation, every magnetic anomaly, every Faraday induction in Earth's oceans was a rehearsal for this exact moment. The 340 kilowatt baseline reactor, running quietly during approach, was effectively a stealth mode. It maintained essential systems, executed trajectory corrections, stabilized attitude, and stored energy for the moment when an external power source could be accessed. Until now, the mission had been conserving energy, operating below detection thresholds of gamma-ray and infrared observatories. The Fermi telescope's 2.8 sigma gamma-ray detection on March 9th was not a casual discovery. It was confirmation of a concealed system functioning exactly as designed. The baseline power was sufficient for concealment, but the real operational power awaited connection with a natural electromagnetic infrastructure capable of scaling outputs by orders of magnitude. The intentional isotopic enrichment of deuterium fuel is also key. At 500 parts per million 25 times the interstellar baseline, this was not random. The fuel ratio was calculated for maximum efficiency over a mission spanning hundreds of millions of years, ensuring continuous muon-catalyzed fusion. Each muon reduces the effective separation of deuterium nuclei, allowing fusion at near-zero thermal conditions. The zero-waste signature observed by Earth-based gamma-ray spectroscopy confirms perfect energy utilization, every neutron captured, no radiation leakage, and no detectable decay products. The engineering sophistication is unlike anything humanity has achieved. The encounter with Jupiter transforms the arithmetic entirely. The terawatt current of the Io flux tube dwarfs Atlas's internal output. By connecting to this planetary dynamo, the spacecraft can now perform functions far exceeding the capacity of its own reactor. calculated trajectory corrections requiring impulsive thrust, magnetic pole anchoring, ocean magnetization circuits, and planetary-scale Faraday wave generation. None of these could have been powered solely by the 340 kilowatt baseline. The flux tube engagement provides the energy margin necessary for executing the mission's grand design. This system is now operating at two distinct energy levels: the baseline reactor for onboard systems and the integrated planetary interface for mission-scale operations. The Jovian flux tube serves as both amplifier and conduit. Atlas is no longer a passive object traversing the solar system. It has become an active manipulator of electromagnetic phenomena, a spacecraft utilizing natural planetary infrastructures to achieve energy throughput unthinkable for human engineering. Every anomaly observed across Earth and the solar system, the synchronized oceanic hydrogen spin, the Cherenkov radiation above magnetic zones, the induced currents in steel hulls, suddenly aligns as part of a coherent energy management and data transmission sequence. The strategic architecture is precise. The trajectory, fuel enrichment, baseline power conservation, and planetary-scale flux integration all point to an intentional design with a singular purpose: collect, process, and transmit planetary-scale data. The Jupiter encounter is the ignition key. It signals the beginning of full operational output, demonstrating that Atlas is not only fusion-powered, but capable of integrating with natural celestial infrastructures to execute energy-intensive processes far beyond our technological reach. This raises critical questions. If Atlas can draw power from a planetary magnetosphere, what are the limits of its energy manipulation? How does this inform the patterns we observed across Earth's oceans and magnetic anomalies over the past months? And what data is it transmitting at this unprecedented energy scale? In Part 4, we will explore the mechanics of this transmission, the feedback loops between the spacecraft and planetary systems, and the implications for interstellar engineering and observational physics. We will trace the chain from Jupiter to Earth, uncovering the mechanisms by which Atlas converts planetary electromagnetism into a coherent data upload, and why this sequence is a milestone in understanding advanced extraterrestrial engineering. As 3-2 Atlas settled into its connection with Jupiter's Io flux tube, the mission shifted from energy acquisition to full-scale data transmission. The terawatt throughput from Jupiter wasn't just a power source, it was a signal amplifier, converting the fusion reactor's precise output into a coherent electromagnetic beam capable of planetary-scale operations. Every Faraday wave, every magnetized ocean column, every induced current in steel hulls was now part of a systematic data encoding process. What had appeared as anomalies across Earth over the past months, the synchronized hydrogen spin in the oceans, the Cherenkov radiation glowing above magnetized zones, the standing electromagnetic waves rippling across tropical waters, was actually a planetary interface designed to transform thermal and magnetic energy into readable information. The design logic is staggering. The baseline 340 kilowatt fusion reactor maintained essential onboard functions and navigational stability, but the moment of full integration with Jupiter's flux tube unleashed the mission's true operational scale. Trajectory adjustments requiring impulsive thrust, rotational synchronization, magnetic pole anchoring, and ocean magnetization, all previously thought impossible under the object's onboard power budget, suddenly became achievable. The Jovian magnetosphere acts as both amplifier and conduit, allowing Atlas to manipulate planetary-scale electromagnetic fields with surgical precision. Every energy spike, every induced current, every harmonic vibration registered on Earth was a carefully orchestrated component of a system transmitting data across interstellar distances. The harmonic resonance observed in Earth's oceans during previous magnetization events is particularly telling. The standing Faraday waves, the sudden 1.5-degree drop in surface temperature, and the coherent oscillation of hydrogen atoms in the water all reflect energy being converted from thermal storage into directed electromagnetic output. The oceans themselves are a medium, a transducer converting planetary heat into a coherent signal guided by the resonance frequency of hydrogen bonds at 10.44 terahertz. This process explains the paradoxical cooling of vast water volumes while energy output increases. Thermal energy isn't being lost, it's being harvested and repurposed as an encoded transmission signal. Meanwhile, the feedback loop between the spacecraft and planetary systems amplifies this effect. The neutrino pulse sequences sent from Earth's core, encoding Fibonacci patterns, were received, processed, and now reflected back in the electromagnetic output. The oceans, the core, and the spacecraft act as a single instrument. The core amplifies, the oceans transduce, and Atlas encodes the data for transmission to a predetermined interstellar destination. Every prior observation, the global seismograph readings, the oceanic magnetic anomalies, and the Cherenkov radiation suddenly aligns as part of a coherent energy management and data transfer protocol. The scale and precision of this operation defy every prior assumption about spacecraft energy limits, planetary interaction, and extraterrestrial engineering. What Atlas is transmitting isn't a message in human terms, it is a systematic planetary assessment. Over 8 months, the spacecraft collected data on Earth's rotational dynamics, electromagnetic infrastructure, biosphere resonance patterns, oceanic heat distribution, and even planetary scale compliance with Fibonacci-based biological optimization. Every physical interaction previously perceived as an anomaly now forms part of a single, integrated observational experiment. The planetary interface was never accidental. Each induced effect, the magnetic grid over oceans, the Faraday wave patterns, the synchronized oceanic hydrogen spins, was a deliberate component of a massive energy-to-information conversion system. Critically, the Jupiter encounter confirmed Atlas's operational architecture. The spacecraft was designed to conserve energy during transit, operate below detection thresholds, and then tap into natural electromagnetic infrastructures at precise points along its trajectory. The engagement with Jupiter's Io flux tube demonstrates the calculated engineering foresight. The spacecraft was built not just to survive interstellar transit, but to execute complex planetary-scale operations in multiple star systems without external maintenance or energy resupply. Its mission architecture integrates fusion power, planetary magnetospheres, and subatomic precision to transform entire celestial bodies into instruments for interstellar data collection. As the Jovian connection persists, the flux tube interaction becomes the primary driver of the mission. The spacecraft now leverages planetary-scale currents to achieve tasks previously thought impossible, providing insight into both the energy efficiency of its muon-catalyzed fusion reactor and the sophistication of its operational logic. The Earth-based observations of ocean magnetization and atmospheric Cherenkov phenomena are no longer isolated anomalies. They are the terrestrial manifestations of a coordinated, interstellar-scale data processing event. In Part 5, we will follow the transmission's journey from Earth to the interstellar medium, explore the implications of using planetary systems as energy amplifiers, and examine how this single spacecraft has rewritten every assumption about advanced extraterrestrial technology. We will trace the complete sequence from energy harvesting to data upload, revealing the full scope of the planetary engineering that makes this operation possible. With the full integration into Jupiter's Io flux tube, 3.2 Atlas has transformed from a high-efficiency fusion-powered spacecraft into a planetary-scale transmitter. The magnetic grid imprinted across Earth's oceans, the standing Faraday waves, and the Cherenkov radiation visible above the magnetized zones are no longer just anomalies, they are components of a massive energy conversion system, channeling thermal and magnetic energy from planetary and interplanetary sources into a coherent interstellar signal. Every observation recorded over the last 8 months, from oceanic hydrogen spin synchronization to harmonic vibrations in the Earth's core, now reveals itself as a deliberate mechanism for converting planetary energy into high-bandwidth communication. The path of this transmission is precise. By using Earth as a medium, Atlas exploits the oceans as a transducer, converting stored thermal energy into electromagnetic energy, while the core acts as an amplifier and stabilizer. The Fibonacci-encoded neutrino pulses from IceCube created a feedback loop that allowed the spacecraft to measure planetary response in real time, ensuring the energy and data were optimally coupled into the signal. What had appeared as random environmental anomalies, the rapid cooling of magnetized ocean zones, the temporary freezing of shipping lanes, and the standing waves across thousands of square kilometers, was actually a carefully engineered global-scale interface. Each effect was calibrated to encode and transmit data efficiently while minimizing disruption to planetary systems outside the observational bandwidth. The scale of energy involved is staggering. The spacecraft's 340 kilowatt muon catalyzed fusion reactor, previously operating in stealth mode, now feeds into Jupiter's 2 terawatt flux tube infrastructure. The combination produces a data transmission system unmatched in efficiency or magnitude. The energy harvested from Earth and Jupiter is effectively being converted into a coherent signal strong enough to traverse interstellar distances. This is not simple amplification, it is planetary engineering using the natural resonance frequencies of water, the core, and the Jovian magnetosphere as components of a vast, distributed processing network. Every physical reaction observed on Earth and Jupiter becomes part of a feedback-controlled computational system, validating mission objectives and maintaining continuous energy and signal flow. The implications for technology and civilization are profound. 3.2 Atlas demonstrates the feasibility of manipulating natural planetary processes to generate and direct energy over astronomical scales. It has miniaturized and perfected energy, conversion, storage, and transmission in ways that dwarf humanity's most advanced infrastructure. The deliberate deuterium enrichment, continuous 8-month fusion output, and near-zero thermal waste are evidence of engineering that not only surpasses current human capability, but operates at a level that integrates quantum, planetary, and stellar physics simultaneously. Every prior anomaly, the ocean magnetization events, Faraday wave mechanics, and core resonance vibrations, was essentially a test run for the final data upload sequence, ensuring that Earth could be effectively monitored and measured as part of a planetary audit. The mission's operational logic becomes even clearer when considering the Jupiter encounter. The I/O flux tube is not simply a power source, it functions as a planetary amplifier, providing terawatt-scale energy throughput that allows the spacecraft to execute the full data upload without relying solely on its onboard fusion reactor. The timing of the connection aligns perfectly with the calculated orbital convergence, indicating that Atlas was designed to conserve energy during transit and only unlock its full capabilities when interfacing with a massive natural power source. This also reframes previous anomalies. What appeared as limitations in spacecraft propulsion, magnetic manipulation, or energy output was actually a deliberate concealment strategy, keeping the object below detection thresholds while maintaining precise mission objectives. The sequence of interplanetary operations now points toward a final objective, transmitting a complete, high-fidelity assessment of Earth's technological and biological development to a destination 180 light-years away in the direction of Gemini. The fusion reactor, planetary-scale dynamo, and interstellar trajectory converge in a system where natural celestial bodies become integral to energy management and communication. This level of sophistication confirms a civilization capable of designing instruments not just for interstellar travel, but for planetary-scale observation and data collection, operating with a precision and foresight far beyond any human engineering effort. Part 6 will reveal the full scope of the data being transmitted, the implications for Earth and its observers, and the ultimate question: what does this mean for humanity? As we watch a single spacecraft orchestrate an operation that turns entire planets into instruments of interstellar measurement, we will trace the final moments of the energy transmission, the completion of the planetary data upload, and what Atlas's mission tells us about civilizations capable of engineering on this scale.